In this video we're going to create this graph. It shows the two forces involved at different vehicle speeds. When the car is going at 0 miles per hour, the centripetal force is 0 on this scale, but there's still frictional force available. As the car builds up in speed, the centripetal force increases and it reaches the point where it equals the maximum frictional force available from the tyres, and it's at that point that the car will slip. And you see we have a result here. The intersection is about 22.5 or just over, and if you remember back at the first spreadsheet, there we have it. At 100 meter radius, 0.1 coefficient of friction, the maximum speed is indeed 22.29. So let's create this graph. On the bottom we have speed. It increases from 0 to 30. So the bottom axis is always the one that we put into the first column. So let's put the speed in. The units are miles per hour. We're going to be converting that, as always, into meters per second because we work in SI units in engineering. Let's begin by putting in the first two. So 0 and 1, highlight both of them, and we want this to go up to about 30. So you can see it's counting there, 28, 29, 30. Okay. Now that's the first column done. Notice that you can highlight, if you've got a sequence going, highlight two of them and use that the black blob in the bottom right hand corner here and drag that down and you will copy. The speed is equal to, in meters per second, is equal to that times 1.6 divided by 3.6. Now I can double click this black blob here and it should copy down automatically, and it has. Let's decrease the number of decimal points. 2 is quite sufficient for this. And now so that's the horizontal axis done. We now need to calculate the frictional force and the centripetal force. The frictional force, FF, let's use centripetal first. Centripetal force is equal to, measured in newtons, and that is equal to the mass, which is 620 kilograms, times v squared, so it's that, and we square it with the up arrow, and divided by the radius, and we've got 100 meter radius here. We're just doing the one calculation. Double click that. I'll come back and reduce the number of decimal points in a second. The frictional force, again in newtons, and this is equal to the mass it's equal to the coefficient of friction actually, times the mass, so it's 8.1 times the mass times acceleration due to gravity. Double click that. Yes, just make sure we get the right number of decimal points. Okay. Right, now we can see that, let's just make that right alignment here, text aligned right, so it lines up with the numbers. Make it bold. We can see that we've got two columns of forces here, and the centripetal force in the first column is less than the frictional force. But as the speed builds up, it reaches a point where the centripetal force is greater than the frictional force. Here it's less than the frictional force, here it's greater than the frictional force. So the actual slip is going to occur somewhere between 22 and 23 miles per hour. in this area here. Just put a board around it so you can see it. Now, how do we turn this into a graph? Well, you simply highlight, you press the A on the top, you press the column heading A, hold down the control key, and whilst the control key is pressed, you click on the C, keep the control key down, press on the D. And then when all three are highlighted, we go Insert. We want the scatter graph. It's very rare that you're going to use the line graph. A scatter graph will put in an x-axis. So do we want the points or just the lines? I think we'll go for that one. And there's our graph. And I can move that to another sheet just by cutting and pasting. And that's the graph. So let's now work out where the intersection is. I can zoom in a bit, make this a bit bigger. The bottom axis is going up to 35. I wanted to stop at 30. So let's you click on the axis. See, it's highlighted the axis now. Then right click, Format Axis, and let's put fixed 0, and the maximum axis, I can change that to 30. Okay, I'm just being pernickety here. I'll let you put the labels in, and then to this intersection point here where the centripetal force exceeds the maximum frictional force, we can show, let's put in where's the toolbar, insert shapes, let's put an arrow in, so click on that, try and draw it vertical, and this only has to be rough when you're doing it this method. It doesn't have to be accurate, providing it's as good as you can make it, and that is 22.5, which ties up well with that value we've got there. So now we've created this graph. You need to put the labels in, horizontal axis with the units, the vertical axis with the units, and a title, and show what the conditions are. This is a coefficient of friction of 0.1, radius of 100 meters. Now this shows the graph without aerofoils. When you add aerofoils to the car, it's going to change. But how will it change? This is where the effort in the project needs to go. How does that graph change when you add downforce?